Hello everybody. Today we are going to continue our lesson about exponential function, and we are going to practice some extra exercises about this topic. Let's start with the first exercise. Consider the function f defined on minus infinity to plus infinity by fx equals 1 minus 2e power minus x. And denote by c its representative curve in an orthonormal system. The first part, determine the limit of fx as x tends to minus infinity and calculate f of minus 1. The limit of fx as x tends to minus infinity, by a direct substitution, substitute x by minus infinity. So it will be limit of 1 minus 2e power minus x, substitute minus x by minus infinity, it will be plus infinity. Then e power plus infinity is plus infinity, multiplied by minus, it will be minus infinity. Plus 1, the answer is minus infinity. Now, f of minus 1, just substitute x by minus 1, it will be 1 minus 2e power minus minus 1, which is e. So the answer is 1 minus 2e. My suggestions is to tell my students, leave your answer in terms of e, don't round it. Don't use calculator here and you round your answer. At the end, when we graph the curve of c, then we round this using calculator and we plot our point as a particular points. But at the moment, use this answer as it is. Don't round it. Leave it in terms of e. Second part. Determine the limit of fx as x tends to plus infinity and deduce an equation of the asymptote d to c. Limit of fx as x tends to plus infinity is equal to limit of 1 minus 2e power minus x. Substitute x by plus infinity. It will be 1 minus 2e power minus infinity. E power minus infinity is 0, as you know from the previous lesson. So 0 times minus 2 is 0 plus 1 is 1. Then, when the limit of fx as x tends to plus infinity is equal to 1, this means that y equals 1 is a horizontal asymptote to the curve c. Now, show that c is below d for every x in minus infinity to plus infinity. To show that c is below d for every x, I should find the difference between fx and the equation of the line d. So y of c minus y of d. Y of c is fx, y of d is 1. So fx minus 1 is equal, according to the function fx, it is equal to minus 2e power minus x. But we know that e power minus x is always positive. Multiplied by minus 2, the answer is negative. So this quantity is negative for every x belongs to minus infinity plus infinity. So the difference between c and d is always negative. This means that c is always below the line d. Let's move now to the third part of our exercise. The curve c intersects the x-axis at a point A and it intersects the y-axis at a point B. Find the coordinates of A and B. A belongs to x-axis, so y of A is 0. In this case, substitute y equals 0 in the original equation or in the original function fx. E power minus x is equal to half. How did we get this? Just substitute y equals 0 in the original function fx. You will get e power minus x equals half. E power minus x equals half, so I can get ex by switching 1 and 2 to get ex equals 2. If ex is equal to 2, then x is equal to len 2 using the property of len and exponential. To move from exponential, we can shift to len. To move from len, we can shift to ex. Ex equals 2, then x is equal to len 2. This property has been taken in the two chapters of logarithmic function and exponential function. And in this case, x is equal to len 2 and y is equal to 0. Then the coordinates of A are len 2 and 0. Here also I recommend to leave len 2 in its term like this. Don't use calculator to round it. Now, b belongs to y-axis, then x of b is 0. Substitute xb 0 in the original function fx. You will get yb equals 1 minus 2. 1 minus 2 is minus 1, and in this case the coordinates of the point b are 0 and minus 1. Part 4, calculate the derivative of fx and set up the variation table of f. The derivative of f, fx is equal to 1 minus 2e power minus x. The derivative of 1 is 0. The derivative of e power minus x is minus 1 e power minus x according to the rules of the derivative. So the derivative of f is plus 2 times e power minus x. E power minus x is always positive, multiplied by plus 2, so it's positive for every x belongs to minus infinity to plus infinity. Now, if the derivative is always positive, this means that the function is strictly increasing over its domain minus infinity to plus infinity. Now let's draw the variation table. The first row is used for the values of x. It's from minus infinity to plus infinity, which is the domain of definition of f. The second row is used for the derivative, which is always positive, as we have proved. And the third row is used for the variation of fx. It's strictly increasing from minus infinity to 1. Why it's minus infinity? Because we proved that the limit of fx as x tends to minus infinity is minus infinity, and as x approaches plus infinity, fx tends to 1. So like this, I finished from the variation table. Thank you for your listening. Goodbye.